Okay, starting Unit 7 today, chemical quantities. A few important ideas that you guys that are online have not seen yet with the term called the mole. Face-to-face people, we've already talked about the mole, but we're going to spend our time now getting back into it. So first of all, let's understand the idea or this concept of a mole. Here we go. So the mole in chemistry is an SI unit for the amount of substance. Okay, that doesn't mean a whole lot to you. We are going to use the word mole similar to the way that you might use the word a dozen or a pair or something. It's a word that means a certain quantity. Okay, so because atoms are so small, it's impossible to count them by the dozens or the thousands or even the millions. So to count to atoms, we use the concept of a mole. And so 1 mole of atoms is equal to 602, and then there's 21 zeros there, 602 and 21 zeros atoms, or 6.02 times 10 to the 23rd atoms. Now it's a complex, real long number. A guy named Amadeo Avogadro came up with the number, doing some calculations and things like that. But for now, before we really get into the conceptual part of this, just understand that this is what a mole is. We're going to show you how we use it, okay? So for any element on the periodic table, 1 mole of that element, or 6.02 times 10 to the 23rd atoms of that element, has a mass in grams equal to the decimal number on the periodic table. So what does that mean? Well, here's the periodic table. Here's a column on the periodic table. All right, so remember this was the atomic number, and then this is the atomic mass. This is the decimal number here. So if I were to say to you, go get me 1 mole of helium, we are able to hold on to helium, you would go measure out 4.003 grams of helium, and you will have gotten 1 mole. So 1 mole, okay, 1 mole, or 6.02 times 10 to the 23rd atoms of helium is equal to the mass, 4. All right, or if I said go get a mole of neon, you'd get 20.18 grams, or argon, is this one. If you were going to get argon, you'd get 39.9 grams. Or if you were going to get krypton, you'd get 83.8 grams. You're going to get xenon, 131.3 grams, and for radon, it's 222. Okay, but so again, remember that this mass equals this number of atoms. Now, that number is gigantic, way too big to even conceptualize. Just know that this is how many atoms are in there. We can't ever get to that or count that. But this number then allows us to have a conversion factor. So let me show you. Let's do a little problem here. So how many moles is 3.79 grams of zinc? Now, some of you are going to get this concept real easily and real quickly and have no problem doing it, but I want you to do the steps that I show here. So the question is, how many moles is 3.79 grams of zinc? Well, it's asking you to solve for moles, all right, and it's telling you you have 3.79. So this is what you need to know. This is the question. And this is what you already know. All right, and we use a process called dimensional analysis to solve for this. So you start by writing what you know. I know that I have 3.79 grams of zinc. Okay, so I write what I know. I'm going to take that and I'll put it over 1. So you see, by putting it over 1, I haven't changed its value mathematically. It just allows me to make an equation here. So that I'm going to then multiply. So we go here, this is what I know, or we'll just say this is what was given. Okay, it was given to me in the problem right there, the 3.79. Now, the next thing is to solve for what you're asking for. So it asks me for moles. All right, and then some smart person somewhere along the line thought that the word mole was too long, so we abbreviated it MOL. So this is moles of zinc. See how that saves you so many letters? Moles of zinc. This is what we're trying to solve for. All right, so it asks me here what I'm solving for. I'll put numbers in here in just a minute, okay? Now, I have to get rid of this, mathematically speaking, because I don't want to have grams of zinc anymore. So what I already know goes down here. I'm going to take the label from the above, grams of zinc, and put that down here. So this is what you've already used. So what we talk about is we take the stuff that we're done with, and what do you do with stuff that you're done with at your house? You probably tuck it away in the basement. We've used it, let's put it in the basement. So we're going to take grams of zinc, put it down there. So we've already used it. So now you can see, mathematically speaking, anything divided by itself is going to cancel. So grams of zinc and grams of zinc will cancel. So the only label I have left is moles of zinc. So I'm solving for moles of zinc by doing this. Now what we need to do is put some numbers in here. Okay, and I told you that the number of moles of any substance, or the mass of moles of any substance, is equal to its number on the periodic table. So we're solving for moles of zinc. So I'm going to find zinc on the periodic table. Here's the table here. Here is zinc. Okay, and I look and find that number right there, the molar mass or the atomic mass. And for zinc, that number is 65.39. All right, so I'm going to put 65.4 right there. That's the number from your periodic table. From the periodic table, okay? And that is in 1 mole. So what I just said here is 1 mole of zinc has 65.4 grams. Okay, so I made a ratio there. Now you follow that? So they've canceled. So now all that's left, mathematically speaking, these are canceled. I'm solving for moles of zinc. So what this problem then becomes is 3.79 times 1, we don't need to do anything with that, divided by, because this is on the bottom, 65.4. All right, now I'm going to erase all this here a minute, because it's going to show back up. I just want to write it out here first. So look at, okay, so here's the number that was given. And when I did it, I put this over 1 here. So we did that. We can't do that on here. So we have this. I think it froze. There you go. So here's our 1 mole. We're canceling those labels out. Now we do that math, and we get our answer of 0.057 moles of zinc. Okay, 3.79 divided by 65.37. Okay, now you got to remember something here. Remember sig figs from way back in Unit 1? How many sig figs are right here? 1, 2, 3. This number comes from the periodic table, so we don't use that one. My final answer should have 3 sig figs. This one, 0.057, actually only has 2. Zeros in the front, not significant. So this number, to write it correctly, should be written as 0.0570. Now it has 3 sig figs. Moles of zinc. All right, so there's an example of that. Let's try another one. Okay. This one says how many grams is 5.69 moles of uranium. So it says how many grams. So this is what I'm solving for. This is what was given to me. Okay, so we just said, write what you know first. I know that I have 5.69 moles of uranium. I'm going to put that over 1 just to get it into this form. So let's label this. This is what was given to me. Okay, it was given to me in the problem. I was asked to solve for grams. So I'm going to put grams of uranium right here. So this is what you're solving for. All right, and down here is what I've already used. And I used moles. So I'm going to put moles of uranium here. And notice that's opposite the way it was in the last one, but we're given different stuff. And remember, these will now cancel. So we just got to put numbers in here. So we look at the periodic table, find uranium, and uranium is 207, I think. This is a good video right now. It's trying to help me find uranium. You probably already found it on your own. Oh, here it is, 92. Okay. So uranium, right down there at element 92. Okay, its molar mass or its atomic mass is 238. So we're going to put 1 mole as 238 grams. Okay, again, these are flipped, but on the last problem, we were given grams and had to solve for moles. Now we're given moles and we have to solve for grams. So those flip. So mathematically speaking, 5.69 times 238. We multiply everything that's on the top, 5.69 times 238, divided by everything on the bottom, which is just 1. So 5.69 times 238. So it's going to go in there. Now, the work is already here. I just like to write it out. So let's go like this. There's the 5.69 moles. And there you go. 1,354 grams of uranium. Now, 3 sig figs. It only has 3. This one has 1, 2, 3, 4. So I need this to have 3. So I go 1, 3, 5. There's 3 sig figs. The 4 doesn't make a 5 go up. We're just going to round it down. So 1,350 grams of uranium. Or we write it as scientific notation. Okay, so there's mole problems. We'll do some more practice with that, but we're going to move on for this one right now. Okay, sometimes we have to do mole problems where you have just a compound, not a straight element. So we have to do what's called molar mass. Okay, so first of all, compound is formed when 2 or more elements are bonded together. We did that in our bonding unit. We just get done with that. You can name all those things. You know if it's ionic, covalent, all that kind of stuff. When finding moles of a compound, then we had to add up the mass of every element in the compound, and we call this molar mass. Okay, this will give you the mass in grams of 1 mole of a compound. Okay, so here's a compound, PbO2. All right, first of all, let's just review what we learned last time. Pb in the last unit, the naming part, Pb is lead, O is oxygen. All right, this is a metal. This is a non-metal. All right, but lead, remember, is one of those special transition metals. It's over here. Not actually a transition metal, but we have to give it a Roman numeral. So there's Pb. So if I do it the way that we do, we have Pb. We don't know the charge for this, but we have oxygen and oxygen, PbO2. Its charge is -2, -2. Total negative charge is -4. So the positive charge has to be +4. There's only 1 lead to put that into, so this is +4. That compound then must be called lead, Roman numeral 4, IV, oxide. All right, now let's get into the actual molar mass of this one. Okay, so when we have to solve for the molar mass, okay, first of all, recognize that you have 2 elements in this compound. There's lead and there's oxygen. All right, there's one lead, and there are 2 oxygens. So what we're going to do now is look on the periodic table and find what is the mass of 1 lead. Here's lead. Okay, so 1 mole of lead would weigh this right here, 207. So I'm going to put that, so 1 times 207. And that equals 207. Now there are 2 oxygens in this molecule, and oxygen is right here. And you see its mass is 15.99. We could just call that 16. So there are 2 of them. 2 times 16 equals 32. So now I go 207 plus 32 is 239 is the atomic mass. We write that as grams per mole. All right, just a minute, let me going to do exactly what I just did there. So remember, this is the atomic mass found on your periodic table. This is the atomic mass found on your periodic table. We multiply them, and then we add them up. So 239.3. Here you have HNO3. Okay, so we're going to find the molar mass of this one. Hydrogen, there's 1 hydrogen in this molecule. Nitrogen, there's only 1 nitrogen, but there are 3 oxygens. Okay, so if you look at your periodic table, the mass of 1 hydrogen, right here, mass of 1 hydrogen is 1. That's going to equal 1. Okay, the mass of 1 nitrogen right here is 14. So 1 times 14, nitrogen times 14 equals 14. And then oxygen, we just said in the previous problem, is 16. So 3 times 16 equals 48. So now I add all these up. 15 plus 48 is 63. So 63, and the label is grams per mole. So just a minute, we got all this work that I just did now coming right here. We add them up, and we got our 63 grams. Okay, here's one more, a little bigger one. This will be our last one that we'll do, and then you have a homework assignment to do for some practice. So I have H4, or NH4,3PO4. So you have 2 polyatomic ions. But if we look at this, how many nitrogens are in this molecule here? So if it's N4, okay, this 4 doesn't have anything to do with the N. So there's 1 N right here, but there's 3 of them inside. So we have NH4, NH4, and NH4. So there are a total of 3 N's, so N times 3. Okay, how many H's are there? Well, there's 4 H's attached to this N, so 4 times plus 4 more. So there's a total of 12 nitrogens, or 12 hydrogens, sorry. And then for phosphoruses, there's only 1 phosphorus. Okay, and oxygen, there's 4 oxygens. Okay, so that's how we get those numbers. Now we go ahead and put those in. And I'll let the program do that. So there's our 3, 12, and 1 and 4. Okay, then we multiply by the molar mass of nitrogen, hydrogen, phosphorus, and oxygen. And all of these numbers here are ones that came right off of the periodic table. So if we look at them, hydrogen is 1. Nitrogen is 14, oxygen is 16, and phosphorus is 31. That's all these numbers that we have right here. So then we can do the math, then we add those up, and we get a mass of 149.0 grams. Okay. So last mole problem, and then we'll call it a day. So what mass is 129 moles? The rest of the problem, okay, of FeNO32. Okay, so before we did moles for a single element, now we have a compound. Okay, the process doesn't change, we just have to figure out molar masses too. So first thing you do is write what you know. I know that I have 1.29 moles of FeNO32. Okay, so we write what we know, or what was given to us. Okay, that was given. Okay, what am I solving for? It says what mass. Okay, so for mass, I'm going to put grams of FeNO32 right there. Okay, so we're setting it up the same way. We just have a compound now. Down here, we're going to put moles of FeNO32. Okay, and we're always comparing that to 1 mole, so we have to figure out what the mass is, and this one we can just leave the 1 right in there. So I have to find the molar mass of FeNO32. So Fe, N, and O. How many Fe's do I have in this compound? Just 1. Okay, there's 1 N inside of the parentheses, but there's 2 sets of them, so that's N times 2. And oxygen, there's 3 oxygens inside of the parentheses with 2 there. That's going to be 6. So 3 times 2 is 6 of them. So again, go to my periodic table, find the iron. Iron's mass is right here. 55.9, so I'm going to call this one 56. Okay. Nitrogen, we said in the last one was 14. 14 times 2 equals 28. Here's 14 nitrogen. has a mass of 14. And then oxygen has a mass of 16. So this one is 16 times 6. Okay, 32, 64, 96 equals 96. So then I add all these up. 56 plus 28 plus 96, 12, 22, 180. And that's going to go here. Okay, so mathematically 1.29 times 180 is what we're going to get. Let me get these out of here. Because remember, these labels cancel. We're just solving for grams. So hang on to that. Put these answers up here a minute. 1.7, 179.8, we called it 180. 232 grams. 3 sig figs, 3 sig figs, all set. We'll get to this tomorrow. That's it for today. We should have a little practice on molar masses and a couple mole problems. Have a good afternoon.